Welcome to this Flex83 Application Enablement Platform webinar with a deep dive into the platform's big data and AI ML processing capabilities. My name is Lee House, and I'm the CEO of IoT83. With me today and driving the discussion is Deep Nair, co-founder and chief technology officer, as well as Jayant Puri, our VP of engineering. Our goal today is to show you some of the big data processing capabilities of the IoT83 Application Enablement Platform, and then show you the intuitive AI and ML workflows that are integrated into the platform. Please feel free to add questions to the chat, and we'll have a chance to field these later in the webinar. And so, with this introduction, I will hand things over to Deep Nair for the presentation. Deep, take it away.
Thanks, Lee. Hi, everyone. This is Deep. And with me is Jayant Puri. He is our head of engineering and the man and the brain behind the product. So wherever I get stuck, he will be my savior. So JP, feel free to jump in. So before we delve into that, we just want to let you know what our prime reasons were for building this product. We started almost 4 years ago and invested in building and transforming this 76% failure rate of IoT projects because we felt that the IoT as a service and data management platforms that exist today, they still do not fill the huge gap and the cost and the uncertainty that exists from taking it from here all the way to the application. So what an AEP essentially does is a collection of tools that allows you to build, run, operate the applications in a very intuitive fashion, and we'll give you a glimpse of that today in the webinar as well. So essentially, if I were to just look at it from a vertical stack standpoint, we are going from connectivity all the way to the applications, intersecting points with business and operations. And we say if you walk this chain, it is very costly, it is very expensive, and it's very risky. So we did a better technical stack, if you would, so that we are easily able to decouple the application business logic from all the rest that you see in blue, so that this is almost always there with you. So it gives you a very good ease of application development. And with that, we will start moving into the platform. So going over the platform, we go over multiple things today. One is what an AEP is. It's a collection of tool sets that allows you to build these applications very fast, and this is what we call as the studios. There is a runtime core that has already been baked and is running 65 million plus devices and dealing with a lot of flows. This whole platform is multi-tenant from the get-go. So I will give you a glimpse of this platform here. This is our core management. It has multiple tenants on it, so we can manage each tenant, each resource, just like what an infrastructure provider does. We do it at the platform layer. And there are these tenants that we have created. We are going to have a tenant with My Apps, which has a lot of tools and applications in it already pre-created. So by default, we have the device management application, which is a multi-device management application that we showcased last time in the webinar. It is a click-to-build, no-code technology, essentially. And coupled with that is the tool set, which allows you to extend that application and or create new applications very fast. So flipping through back, what do we do? We not only handle the cloud, but we also handle the edge. There are tool sets that are available in this, which allows you to manage an edge device. Now, every deployment in IoT has these two components, the cloud and the edge is comprised of deep edge or different topology. So how do we handle that along with the cloud in a very converged fashion? We allow that to be done from the platform itself. So the other thing that we wanted to highlight is from a connectivity, the embedded side and the sensor side, you can bring in any type of device with any type of data. and apply your technology set that you want. The system supports all of these tool sets and all of these data stores combined with the big data infrastructure, that you are able to create your powerful applications, the bespoke applications that you want very fast. And over the last 3 years, we have been able to transform the time to market by 6x to 10x overall for the projects that are launched and built on top of Flex83. So today, when we go into AI ML, every AI ML is a walk. The walk starts with very simple things, from threshold crossing alarms, which we say can exist very easily in a click to build fashion. As you go into the operations field of no device management and you go into threshold crossing config, you are basically clicking your way of building those alarms. Internally, those things starts to act on the streams, the ETLs auto starts, and then you're looking at the stream on a per packet basis to see, okay, whether my threshold has crossed or not, and then what happens when a threshold crossing happens, whether you want to alert or not, or you want to create events which are multivariant in nature. So, and the last piece which comes into the fast and custom algorithm is which provides you full control of how you want the system to react on certain conditions should what is provided in low code or no code technologies fail to address that. And then later on, how does this transform completely into an AI ML infrastructure that allows you to graduate from more or less rule-based working to a more auto ML, MI, or AI generated working from supervised or reinforced or unsupervised mechanisms. So these tool sets allow you to walk that path, and we are going to go over the various pieces as we go over. The very first piece is the connection management piece, which means what all sources we are able to get the data from and what all things we are able to send the data to. So if I just flip over to the dev tools, we have a number of connectors that are available. This is a subset of all the connectors that we have in the pipeline. And I'm just going to highlight a few pieces of these connectors. On the very top, you will see that these are all streaming connectors. Then you go into the next, which are more or less file system based connectors. Then we get into the data stores. Then we get into applications. And then we get into the device management place. And here we continue to add more custom connectors that you require as part of the mechanism. And should you need to extend additional connector space, there is a marketplace available which has Node-RED and other technologies available with it, which you can just launch and continue to extend the system with anything that you want as your source and sink. The difference between a marketplace-based connector and a connector that resides here is that these connectors are interlocked with the rest of the platform system so that they can feed directly into the ETL big data infrastructure. So once these connectors are done, if I just showcase you any one of them, let us showcase the Cassandra connector. So when I start to create this connector, we can just look at every connector have their subtleties and nuances to it, which you can see, okay, what key space and what are the credentials that you want to do. By default, we are trying to create a system which remains secure. But should you have a need where it is an open TCP connection, the system does allow you to get to the system using a TCP connections, but using access mechanisms to control who can get to the system. And there are additional security parameters that can help you secure those seemingly insecure connections. Then we get into what does this connector, when it is sending data to the system, how does it start interacting with the transformations? And here is how we get into the ETL scope. So from the presentation standpoint, we have moved from connection management into the big data infrastructure for dynamic data management. This is backed by Apache Spark. And then we go into how do we actually write a Spark job in a very easy fashion. So as you can see here, there are multiple jobs that we have already written. They have different source and sinks. They are of different types. They are streaming jobs. They are batch processing jobs. They can be created or updated by different users of the system. And whoever does that is accounted in a way that every engineering effort that is going into building these jobs is being tracked and audited as and can be audited as well. And and then we have all of these development functions that you see on the right hand side. So I'm just going to edit one of these streaming jobs to showcase how what does it really entail when we how do you easily write a Spark job without understanding Spark itself. So the very basic thing is on the right, you just name your job. And here you have this metadata on the bottom left that you see here: max, offset, trigger interval, and thresholds. This is to control what is the level of operations that you want your big data infrastructure to apply for this job. And by just tuning that, you can scale from dealing with tens of transactions per second in the POC to millions of transactions per second as you get into production. Without So the same job can be tweaked from this metadata. Now here are all the sources available for this data. These is all streaming sources because the job was streaming. You say, okay, all of these devices types that I have, if and the topics available to that. So this is the source piece that you can select. Then you can do a definition of that. As you go into this information, the definition exposes a few things, which is what selections you want, aggregations on filters, and you can add different operation capabilities onto it, and then you can say where I want to send this data to. And while you are operating upon this data, whichever stream you have picked here, you will see all the information that is coming on that topic or on that stream on your right hand side. And you have the ability to invoke any of your Spark functions as you're writing your logic here for aggregations and filters or transformation. Um, you have also the ability to write UDFs, which is user-defined functions, and call them in your jobs that you're writing, and then direct it to a particular sink. So before I go further, I'm going to go back here and try and create a new ETL so that you get to know how easy it is to do that. So let me say that this is my new web test ETL, and I'm going to pick information, let's say on MQTT channel, let's say from an energy sensor, which is sending me information on this particular topic. So as I'm clicking, the system behind the scene is prompting me to the knowledge that it has gained about those streams. Now it says, oh, I have all of these information that is being sent by an energy sensor out there in the field. It is giving me current, resistance, and voltage. And I say, okay, let me start writing a very simple job. And the only thing I'm doing is taking this job and selecting everything that I have, raw data, and putting it into a sync point. And now I'm just say, okay, which sync point I want to send it to. Let me say, okay, this is going to go into a NoSQL database. Let it be Mongo, Cassandra, or Influx. Let it be a Cassandra database. And the connectors that we had created in the connectors logic for Cassandra we are available. So if you have multiple connectors, you can connect. And here the system is prompting for validation, and we say, okay, this is my energy table, for example. And then what is the partition key? Let it be the timestamp. So the subtleties that those data stores need at the very top level are provided to you from on this interface. So you don't have to worry about what is the scaling and the way Cassandra is launched. So all of that is pre-done or pre-baked for you. And all you are doing at this point in time is writing and focusing on the business transformation that you need. and then you just, as I just saved this information will find its way that every packet is going to go and land in a Cassandra data store that for which you have created a connector. So going back to the ETL pipelines, we mentioned about different source and sinks here, and we mentioned about the UDFs. So one of these jobs would be using the UDFs, and when we go into UDFs, you will look, and I start to add a UDF. Let me just give you a glimpse of what a UDF can be. Here, this is a very simple prediction UDF, which is which, when it receives a packet, it is calling us. You can see here it is calling a deployment. It's calling the model for prediction. Sorry.
I think it's just calling the AWS SageMaker endpoint at that point. Or
No, here, JP, this is calling an internal endpoint here. And so there are multiple interpreters that have been given. We have JavaScript, we have Node.js, and we have Python, on which you can write your UDFs and submit them and use them in the pipelines. Then we go into the ETL schedules, which is needed for when you start doing all the batch processing, and different batch processes can be run, which is a 15 minutes aggregates, an hour aggregates, a day aggregates, and what have you. And just giving you a glimpse of this view in terms of when this batch ran and what was the execution status of this batch. And if I were to just try and stop this and give you an edit view of that, this ETL batch ETL was written, and it has the cron of hourly, daily, and custom. And when you go into customs, you can actually write any of your mechanisms that you're familiar with from a cron standpoint to create your schedule. So let me just restart this. Then we get into the more interesting piece, that we have what we call this as the citizen interface, where you do not want to write the code, but you know what transformations to do. This was an easy interface of picking up your data source and your sinks plus the transformation. And now we have provided also the ability to write your notebooks. Essentially, what it gives is a full code. You can actually write your Spark job and submit it to the system. And you can see here that this Spark job is cron enabled or not. Here you are writing your actual code base, and I can write it in different code blocks and can submit it. You have the full functionality of an IDE, like to test drive it, look at its various outputs before you submit the Spark job from a production standpoint. And if I just do debug on that, I can debug it as to what my Spark job is doing. So the platform acts both like an operational tool as well as a development tool, and development can happen both in a citizen format as well as in a serious coding environment. So all of these transformations allows you to track everything that is coming from connectors and be able to operate it on a very high scale, high performance nature standpoint. So the transformations then finally lead us into the data stores, and we have different types of data stores here that you will be requiring as a user of that. If you have heavy read requirements, you may want Mongo. If you have heavy write requirements, you may want Cassandra. If you have heavy regular expression search kind requirements, you may want Elastic. If you have relational, you may want MySQL. So let's say I'll just show you one of these time series store. I think it has one of the data stores which is having millions and millions of records. So again, the idea is it's a baked data store out there, just like a managed service. So you don't have to worry about scalability. up to a certain point. So from here onwards, we'll start to get into the next stage of the platform, which is how AI ML starts to interact with the information that is coming from the connectors and the transformations. So we switch over into AI ML, and but we also talked about the Lambda architecture, where you can write any of your code base and supply the information with the Lambda functions. And if I were to just give you a glimpse of that, uh, you can write your code base in 7 or 8 different languages, and submit this code base to the system to run based on what kind of memory you want this process to run. Again, you have different sample codes available to help you assist as a developer to write this code base. And they can then get converted and tied to an API through an API gateway function, which uses like a Swagger-like interface to do that. Very simple click to build technology of binding your Lambda functions to an API. Now, this API can be scheduled, and henceforth you can in any of your ETLs can invoke this API, and by invoking this API, you're essentially invoking the lambdas behind the scene, and thereby tying, very extensively the workflow that you want to create for your application. So going into AI ML piece now, there are multiple layers that we have provided here, from a full custom ML to the very auto ML generated trends and forecasts. So these trends, I will start from trends and forecasts. These are applied basically on any telemetry stream of data that is being received.
Just select the pump station from the right and should show the data.
Yeah, thank you. So what I'm selecting here is multi-device management part. So there are multiple devices that are sending data to the system, and they're of different types. And here, whatever telemetry data is being received, that is auto ML behind the scenes to provide you 3 things: the trending, the forecast, and beyond the forecast, it is seasonality, which is not added here for now. So similarly, you can achieve it for your different telemetry data and see what the system is telling you before you start to get into, okay, now I want to apply my own more refined logic of doing my ML AI on the data that we are receiving. So going into these details of data ML, so we'll start with what is the top line in terms of your custom ML. This custom ML allows you, if I just go and edit this, it allows you to walk through different paths. You can select where your data store is. Here we are selected, in this particular case, it is coming from a file that is stored in Amazon. We can say, okay, this particular file has this connector information, which was set up here at the connector level, and the corresponding bucket in which this file is there. So when the system looks at that, it says, okay, here is all the parameters that exist in this file. What do you want to do in cleaning and transformation of these parameters? Now, there are different tools that can get applied here, from null value check and what do you want to do with cleaning it up or transforming it. And you can start to apply different tool sets, packing, regression, expression search, and whatnot. In here, all the tool sets are available, and you can apply that on one or more parameters by just adding that here, add a new column. And then it gets into the feature selection. There are multiple feature selections, from correlation, information gain, and constant removal. And then we finally get into the model building phase of regression, classification, anomaly clustering, XBoot, and you can select different algorithms as you come and select the top algorithm here and give its hyperparameters of selection. So this is how you can run your entire AI ML from here on your data sets that are residing in different places. So now moving into the other spectrum, where you have, let me just look at and run some AutoML on my data stores. Now here, the easiest part is that if I just preview this piece, it allows me to do everything that I did with custom, but more with the click technology. And here we are saying, here was my data store, the same connector, just tell me where the column is that I want to predict, and only about my information about my algorithm to use. And that's all the system takes it, and behind the scene it runs AutoML engines to start doing the prediction. So I think I have a few places where I had set up uh, these information elements of, okay, what happens when I do a correlation on this, and when I do some missing value or data set. So this we have pre-done. So I'm just going to give you a view of the correlation that happens behind the scenes when we are looking at temperature, pressure, gas, humidity, and EC2O. And this is how the system tells you this is the correlation matrix for the data that is being received. Then we go into the details of, okay, what is the null values in this. They say, okay, temperature had so many times and pressure had so many times in terms of missing value status on that. So then we get into, okay, and this was the sample data against which things were generated. So now that the data model has been built, now, how do we deploy this model in the system and then start applying it for predictions? So that brings us back to this picture of AI ML, and we say we have to deploy the models. So we deploy the models here. We can go to external models or deploy these internal models in the system. And one such model that we had deployed was for the training that we had done here. And if I were to just go and invoke this model from the standpoint of, let me look at its output, I gave a certain number here. Let me just change that to some one of these numbers here, and you will see that the prediction would change accordingly. And if I were to give the prediction that exists in this data itself, it should exactly match the training data or close to that for prediction. So this is how you start engaging the system from AI ML and start putting models into the system or invoking models externally built from the system to get the inference from it. So going further, we have other things about audio sentimental analysis built in. So if you allocate a file to the system, upload the file and select what kind of duration, removal, noise removal, polarity, word count that you want. You can select existing categories of words, and the system gives you an output of that running the audio engines behind the scenes, and it gives you a view of your recognition, like who spoke when, for what time, what is the confidence level for that. You can play it, and finally it also gives you the word count. And if you look at the word count from an image standpoint, it gives you which words were spoken most. Then we get into other interesting pieces of object recognition and face recognition. Here we have provided information about, let's look at training the model. You give a set of images and to the system and ask the model to train and deploy, and then you can upload different images to the system to say, okay, how does this system look at matching. So let me just try and see if I have any picture of Chris available. I do have Chris. So, and it will give us a prediction cost of what from a face net recognition standpoint. The similar things was done for object recognition, and by that definition, you can give a stream of images, which is video, and it can start predicting in that video if you are doing any object recognition or face recognition, to make it easier for you to build those applications which have been so difficult to do so far, by tying all of these technologies set together. So Nishant, I think we have covered almost everything in this 30 minutes fast track. Anything to add, Lee, JP?
Oh, I think there were some Q&As, and one of the question was like, is the system able to import external ML models such as .pm ML or Onyx or or any other like Weka?
So we can bring in the PMML and the Onyx, both the models. So it's like we have multiple environments, like that runs on Spark and then Keras, and also all those models which are even trained on other technologies can be brought in. So we support multiple runtimes. The PMML being for the Spark. So if the people use our system for AutoML, then the generated model is a PMML file. If they want to bring in their file, which is basically the upload file option, they can just upload any model and select the runtime. So if you just kind of deselect this, you can just show the runtimes that are available with us. So in this version we have 3 runtimes available. So these are
So
the types of runtimes that we support. So any model which is a protobuf format which is built on TensorFlow, or any model which is a pickle format which is built on Keras or Skykit, or any model which is based on Spark and which is of the form PMML, all these runtimes are supported by us, and we are continuously adding more and more runtimes as we basically enhance the system.
And another question is, how about data cleaning and observability of Spark jobs? So Deep, if you can pick that. And
So basically the data cleaning, if you go back to the ETL part, we have an option of the cleaning of metadata, and the life cycle of the ETL jobs are all controllable on the platform. So whether you write a Spark job which needs some metadata cleanup, or some other kind of cleanup, that is all possible on the platform, and these tools on the right just provide with those options. So all those are available as standard options when you basically do some operations on the written ETLs.
so one of the requests that we got is about dynamic ETL on the Rapid Application Development Platform.
so dynamic ETL allows us through this interface to write any piece of code. If I were to just go back, and here we were looking at different inputs. So if I just switch it to batch processing, I get different sources of data versus the stream processing. Whenever I select a particular source that already exists, you see the green circle here, that this source has all of these device types are sending data on this source. And so whichever source that we pick, let's say we pick this Wi-Fi analysis, and we look at the data against which topics it is sending, and I pick that information up. If topic is available on that, we will start to get the data here on my right hand side. So let me just the moment I start naming it, I start to get all of this information that you see that this is being received from a Wi-Fi router, which is sending us information about the packet structures and the receive and the transmit bytes that they have. If I move it to an energy sensor, for example, and look at its topic, it immediately gives me what is being received from that. If I move to any other device, it gives me that. And now I can pick up the source, and then I go into looking at the definition. If once I have done a selection, and here it's easy selection, then I can add another block to that and say, let me do an aggregations on it. And I can do group by window aggregations and select different conditions. I can write filter conditions here for different operations. And once I have done this selection of what we call as dynamic ETL, what we do is we go and look at the sync point. And the sync point is, again, depending upon whether you want to hit stream, you want to send it to a cloud storage like S3, you want to send it to a SQL data stores or NoSQL data stores, or third-party managed services. So these are the categories. And based on the categories, you have the further selection of the protocol that is running on that category and the corresponding connector that you have created, by thereby giving you full flexibility of picking information up, writing your code, looking at the sync, all with clicks and very low code, where you can invoke any of the math functions here while writing your transformation. And should you need, you can write your UDFs as well and invoke them.
Deep, you can just show everyone on call that how we can sign up, and there's a 1 month free trial and a bit about pricing. That would be great. So anyone on the call, they can bring up their engineering team, get this kind of vetted by them, and see how their use case can be solved, and then we can set up a one-to-one call as well.
So on our website, IoT83.com, we have this sign up for free. You just click there, it lands you to the sign up page. All you have to do is give your tenant name. This is like my tenant, for example. The system will tell you whether this is available or not. And you just give your organization name, just the name, and your email. And the CAPTCHA will ask you if you're not a robot. You just do that, and then you do sign up, and you are done.
Deep and JP, that was a great overview of really just some of the powerful low-code tools available in the Application Enablement Platform. That was also a great overview of the AI ML tools and workflows available. We hope you enjoyed this overview. If so, please sign up for your own Flex83 trial account or reach out to us for a first-hand demonstration. We would love to take you through the platform and work with you to solve your unique IoT or digital transformation problems or challenges. So from all of us at IoT83, thank you for joining, and do watch for our upcoming deep dive into working with our low-code dynamic extract transfer load capabilities. Thanks again for joining.